In section 4.3, we are going to continue working with matrices. And as I told you in the last section, augmenting these matrices, which was the title in 4.2, is really what we're doing here as well. It's called Gauss-Jordan elimination. The primary difference is we're going to see how to do it when our matrix becomes larger than a system of two equations with two variables. Now, let me just remind you before we start that when a matrix is in reduced row form, that means, I'm going to draw an illustration for you here, that if it's the same size matrix we've been working with, a system of two equations with two variables, the uppermost element in the top row left is a 1. So we would have 1, 0. We're going to see that vertical line, and then some number will appear to the right of the vertical line. The second row has to begin with a 0, and then we would have a 1, and then to the right of the vertical line we would see what the answer element is for the y-coordinate. The top row to the right of the vertical line gives us the answer for the x-coordinate. The second row to the right of the vertical line is the answer for the y element. Now, as we move into larger matrices, let's say we're going to work with 3 equations with 3 variables. Those are doable still with substitution or elimination, but they're a lot more cumbersome to work with. It's a lot more to keep up with and more tedious on the algebra. So this is where matrices can really save some time once you know how to work with matrices correctly. So if we were looking for reduced row form for a system of 3 equations with 3 variables, our top row would be 1, 0, 0, and then to the right of the vertical line is the answer for the x value. Middle row would be 0, 1, 0, and then we'd see the answer for the y. And then the bottom row would be 0, 0, 1, and then we would see the answer for the z variable. So remember, what we're looking for is to the left of the vertical line. Every element will be 0 except we will see 1s show up on the diagonal from top left in that first row moving down to the bottom right in the last row. We would say to the left of the vertical line, our matrix is a square matrix. In other words, if you look at the first one we did, we would have 2 rows and 2 columns to the left of the vertical line. If you look at the second one, we would have 3 rows and 3 columns, the same number of rows and columns to the left of that vertical line. That's going to be important if we're working to solve these systems. Now, the rest of this page simply goes through the steps, reminding you how you would put something into reduced row form in order to see what the solution is. I think we're ready to look at the next slide. Now, all this is asking you to do is to determine if the matrices are in reduced row form. Now, because of formatting, excuse me, I couldn't get these to print out in completed bracket form for matrices, so let me add in what you would need to see. That's what it should look like on number 1. And if the question is this in reduced row echelon form? The answer is yes. And the reason is because, and I'm writing that RREF for a reason, reduced row echelon form. We'll come back and talk about it at the end of this lesson. But notice you have your 1s on the diagonal. The rest of the elements to the left of the vertical line are 0. So nothing needs to be done to this matrix. You can recognize the answers in the form that it's written. Now, if you look at the next matrix, let me put the symbols on there that we're missing. And the question is it in reduced row echelon form? Well, do you see ones on the diagonal on the left of the vertical line? The answer is no. I have something that's out of place. Remember, I want a 1 on the top row in the furthest position to the left. It needs to be in the first column. And then I would have a 1 on the bottom right in the last row. Now the last row is good, but look at what's wrong with the first 2 rows. I'm supposed to explain what I could do to put it into reduced row echelon form. And notice if I simply switch row 1 and row 2, I'll be there. So that's what I will identify. If I switch row 1 and row 2, then I will be in reduced row echelon form. Now, third matrix, once I get the markings on here, if we look at this, is it in reduced row echelon form? Well, the answer has to be no. And the reason it has to be no is because notice we have an element that's not a 0 or a 1 to the left. If you see a number that's not 0 or 1 to the left, it's impossible for it to be in reduced row echelon form. And this 4 needs to become what value? It needs to become a 0. So in order to make that become a 0, I will need to back up to row 2, and if I multiply -4 times row 2, and I add that to row 3, and make that my new row 3, I should be in reduced row echelon form. So nothing will change on the first row. Nothing will change on the second row. But for my third row, if I multiply row 2 times -4 and then add it to row 3, -4 times 0 is 0. 0 plus 0 is 0. -4 times 1, and we're working here with row 2, -4 times 1 is a -4. And if I take -4 plus 4, that will give me a 0. And then if I multiply -4 times 0, I get 0. And 0 plus 1 is 1. Now don't forget to take care of the answer column, because -4 times 1 is a -4, and -4 plus 11 gives you 7. So now we have that in reduced row echelon form. We're going to now look at solving these matrices, not just getting them into the form. So move to the next slide. To save a little time, I want you to see if you can use Gauss-Jordan, which we did on the last lesson, and see if you can come up with the solution on these. Now, what I'm going to do is just tell you what the solution is on the next 3 problems, give you an opportunity to practice to be sure you can actually get these values. On number 4, you should end up with the ordered pair 2, 0 when you finish using Gauss-Jordan. On number 5, you have a couple of fractions. You should get 4/3 and 1/5 as your ordered pair. And for number 6, your solution set should be 3, -2. So good luck on those. Make sure you know how to do those correctly. What I want to show you now is what happens when you get more equations and more variables. So move to the next slide. On number 7, one thing that looks a little different is, first of all, we don't have x's and y's and possibly z's. We have our variables subscripted. Now, a subscript simply tells us about position. So when you see this x with a small 1 kind of written below to the right of it, that's basically just telling us this is the variable in column 1. When you see the x sub 2, That's basically telling us we have a variable in column 2. Now, what I'm going to encourage you to do is, even though there are only 2 variables showing, we have 3 equations. So I'm going to tell you I would make a square matrix. We want to have, since I have 3 equations, I'm going to have 3 rows. I also want to have 3 columns to the left of my vertical line. So what will happen is when I move across this top row, I have 2 in the first spot because 2x sub 1 is that first element. Then I'm going to have a negative 1. There is no x sub 3 in my equation. Well, that's because the coefficient would have to be 0 if it were there, and 0 times anything is 0, and we wouldn't write that down. So I'm going to make this third column, and I'm going to put a 0 there. My answer was negative 4. Okay, row 2. I have a 2, and I have a 4. I do not have a third variable, so I have a 0, and then I have a 6. Now, one thing I want to caution you about is if these had been maybe x's and y's and z's, it's possible that we might have had an equation that had an x and a z, and the y was missing. So you have to be sure that you put them all in the right column. It doesn't necessarily mean that you're going to end up with zeros in a third column every time that you only have 2 variables, but there were 3 equations. So just be careful you put them in the right place. Your last row will be 3, negative 1, third column is still 0 because I don't have an x sub 3, and a negative 1. Now, in order to solve this, remember we start by trying to make the first element in the first row be a 1. And right now it's not a 1, it's a 2. Now, I can work with that row, and to turn it into a 2, I would need to multiply through by 1/2. When I do that, I can see it's going to give me a fraction in the second place, in the second element of that row. One thing that I notice I can do, and it's perfectly okay if you decide to do 1/2 times row 1 on your first step, but look what happens if I switch row 2 and row 1. If I multiply row 2 times 1/2, I won't get any fractions. So I think the first thing I want to do is switch row 1 and row 2. Not required, but it's definitely an option on what you can do. By doing that, I'm going to have my 2, 4, 0, 6 on the first row, and then I'll have 2, negative 1, 0, negative 4 on the next row, 3, negative 1, 0, negative 1 on that row. Now I can take 1/2 times row 1 and make that my new row 1. When I multiply through, that's going to give me 1. 2 times 1/2 is 1. 4 times 1/2 is 2. 0 times anything is 0. And 1/2 times 6 is 3. Second row has not changed. 2, 1, 0, negative 4. And 3, negative 1, 0, negative 1 is my bottom row. Okay, so my top row, I have a 1 in the upper left corner. What I need to do next is to get the second row, first element, to become 0. So the way to make that happen is I can multiply negative 2 times row 1 and add that to my row 2 to make my new row 2. Alright, first row is good. Second row, if I multiply negative 2 times row 1, negative 2 times 1 is negative 2, and negative 2 plus 2 is 0. Negative 2 times 2, I'm now on the second element in this row, negative 2 times 2 is a negative 4, and negative 4 plus 1 is a negative 3. Negative 2 times 0 is 0. 0 plus 0 is 0. And then to get my answer column, negative 2 times 3 is a negative 6. Negative 6 plus negative 4 is a negative 10. Bottom row has not changed. All right, what I would like to see happen now is for, in the second row, I want that negative 3 in that second position to become a positive 1. To make that happen, I can multiply a negative 1/3 times row 2. And that will be my new row 2. Okay. 1, 2, 0, 3 on the top row. If I multiply everything in the second row by negative 1/3, I have 0, 1, 0. Now if I multiply a negative 10 times a negative 1/3, I will get a fraction, and it's going to be a positive 10/3. And that's okay. Fraction is going to be unavoidable at some point in here, most likely. Bottom row, 3, negative 1, 0, negative 1. Okay, ready to look at the bottom row. I need to turn the 3 into a 0. To make that happen, I'll have to multiply negative 3 times row 1 and add it to my row 3 to get my new row 3. All right, 1, 2, 0, 3 on the top row. 0, 1, 0, 10/3 on the second row. Now for my bottom row, if I multiply negative 3 times row 1, negative 3 times 1 is a negative 3, and negative 3 plus 3 is a 0, which is good. That's what I was hoping for. That's what I'm aiming for. Negative 3 times 2, when I go to the second column, is a negative 6. Negative 6 plus negative 1 is a negative 7. And then 0 plus 0 is 0. And if I multiply a negative 3 times a positive 3, that gives me a negative 9, and negative 9 plus negative 1 is a negative 10. Okay, I need that negative 7 in the bottom row to become a 0. So in order to make that happen, I will need to multiply negative 1/7 times row 3 to get my new row 3. Oh, no, I'm sorry. I don't want to make it a 1. I want to make it a 0. So I need to multiply. Let me erase that. I apologize. You have to stop and think sometimes about what you're doing here. So because I want to make it a 0, I'll multiply row 2 times 7 and add that to row 3. And that will become my new row 3. All right. 1, 2, 0, 3 on the top row. 0, 1, 0, 10/3 on the second row. And then on my last row, if I multiply the second row times 7 and add it to the bottom row, I'm going to have a 0. I'm going to have a 0. I'm going to have a 0. Now to get the answer column, 7 times 10/3 becomes 70 over 3 plus a negative 10 over 1. If I get a common denominator, I've got to multiply the negative 10 over 1 times 3 over 3. That becomes a negative 30 over 3, and 70 plus a negative 30 is 40 over 3, and I have a problem now. Because if I look at this bottom row, that is a contradiction. I have zeros for every element on the left side, and that would say that 0x1 plus 0x2 plus 0x3 is equal to 40 over 3. That means there is no solution on this one. Okay? Simply because there were only 2 variables in the equation, but we had 3 equations. That in and of itself doesn't mean there will be no solution. Sometimes there will be. You just have to work it out to see what you get. Now, if you look at this equation, it is another system that has 3 equations and 3 variables this time. So when we set this up, and again it has the x1s, the x2s, and the x3s. Let's put it into matrix form. My top row is 1, -1, 1, and then I have my 0. My second row is 2. Now let's see if I can get it to where, there we go, 2, 3, 5, and 1. My third row is 3, 2, 4, and 7. Now, my top row, I'm starting off well because I already have a 1 in that first element in the top row, so I'm ready to work with row 2. I want to make the 2 in that middle row turn into a 0. So to make that happen, I'm going to have to multiply -2 times row 1, add it to row 2, and that will become my new row 2. Alright, so top row is still 1, -1, 1, 0. My middle row now will be -2 times 1 is a -2, and -2 plus 2 is 0. -2 times, move to the middle column, -2 times -1 is a +2, 2 plus 3 is 5. -2 times 1 is a -2, and -2 plus 5 is a +3. And anything times 0 is 0. So 0 plus 1 is 1. Haven't done anything with my bottom row yet. So far, so good. All right, I would like to have this element right here, that 5, turn into a 1. To make that happen, I'm going to multiply 1/5 times that row 2 to get a new row 2. All right, top row is still 1, -1, 1, 0. My second row, when I multiply by 1/5, will turn into 0, +1. Now 1/5 times 3 is a fraction, it's 3/5. And then 1/5 times 1 is 1/5. And my bottom row is still 3, 2, 4, 7. Okay, so I'm good on the top row for now. I'm good on the second row for now. I need to make, on the bottom row, the 3 become a 0. For that to happen, I need to multiply -3 times row 1, add it to row 3, and that becomes my new row 3. All right, I still have 1, -1, 1, 0 on the top. I have 0, 1, 3/5, 1/5 in the middle. Now for my new row 3, if I multiply row 1 times -3, -3 plus 3 is a 0. If I multiply -3 times -1, that gives me a +3, and +3 plus 2 is a 5. If I multiply -3 times 1, that's -3, and -3 plus 4 is a +1. 0 times anything is 0, and so 0 plus 7 is 7. Here's where we are right now. All right, in that bottom row, I need that 5 to become a 0. So to make that happen, we would need to multiply row 2 times -5, add it to row 3, and that will become our new row 3. Top row doesn't change. Second row doesn't change. Now for my bottom row, If I multiply row 2 times negative 5, first element will stay 0, and 0 plus 0 is 0. Negative 5 times 1 is a negative 5, and negative 5 plus 5 is 0. That's why we chose to do this. Now if I multiply a negative 5 times 3/5, that's going to give me a negative 3. Negative 5 times 3 over 5. 5's are going to cancel, and I'm going to have a negative 3 for this part. I still have to add it to that element that's in row 3, which is a 1. So negative 3 plus 1 is a negative 2. And then if I multiply negative 5 times 1/5, that's going to give me a negative 1, and negative 1 plus 7 is 6. So we completed that row operation. We're really close. The last thing that needs to happen in this bottom row is the negative 2 needs to turn into a positive 1. So to make that happen, we would need to multiply everything in the bottom row by negative 1/2. And that would become our new row 3. All right, top row. Second row is still the same. But our bottom row, when we multiply through by a negative 1/2, we get 0, 0, positive 1, and then 6 times negative 1/2 is a negative 3. And the bottom row is completely finished. Now let's back up to row 2, and I need to make this element become a 0. To make that happen, if we were to multiply row 3 times negative 3/5 and add that to row 2, for our new row 2, I think we'll be in good shape. So we have 1, negative 1, 1, 0. Now for row 2, if I multiply the bottom row times negative 3/5, 0 times 0, or 0 times anything is 0. So 0 plus 0 is 0. 0 plus 1 is 1. Now when I multiply negative 3/5 times 1, I get negative 3/5. Add that to positive 3/5, that turns into 0. For my last element, I'd need to take negative 3/5, multiply it times negative 3. Okay, that's going to turn it into a positive 9 over 5. But then I have to add that to the element that was already in row 2, which is 1/5. Well, a nice thing happens here. 9/5 plus 1/5 is 10 over 5, which reduces to be the whole number 2. We finally got rid of that fraction. So the second row's complete, third row's complete. What we need to do now is go back and make to the right of that 1 in the first row. Those need to become zeros now. So if I simply add row 1 and row 2 together and make that my new row 1, I'm going to have 1, 0, 1, 2. Second row does not change. Third row does not change. And the very last thing that needs to change is this element right here in the first row. And I can make that become a 0 if I subtract row 3 from it. So if I do row 1 minus row 3 and make that my new row 1, I will have 1, 0, 0. If I take 2 minus negative 3, watch your signs. 2 minus negative 3 turns into 2 plus 3, which is 5. 0, 1, 0, 2, 0, 0, 1, negative 3. I now have this in reduced row echelon form. That means my answers are to the right. You can express your answer as an ordered triple instead of an ordered pair. And that would mean that in the first, the x1 variable, the answer was 5. The x2 variable, has a value of 2, and the x3 variable had a value of -3. So the ordered triple 5, 2, -3 is your solution. Next slide. What I want to do is skip over this next problem, number 9, for right now. We're going to come back to it in a little bit. And I want to walk you through how to do number 10. Now, again, we've got x1s, x2s, and x3s instead of x, y's, and z's, and that's okay. And don't worry about the funny looking eyes, that's just a formatting thing. Let's pull this thing out of equation form, put it into matrix form. That means our top row is 2, -3, -13. To the right of the vertical line we have 14. Then 3, -8, -30. And then to the right of the vertical line we have 28. 1, 2, 4, 0. So that's what our matrix will look like. Now, you've got some options on what to do here. One possibility is, since we have in the bottom row a 1 is the first element, we could switch row 1 and row 3. If you wanted to multiply the top row by 1/2, that's certainly an option too, but it will create some fractions for you. So if you're trying to avoid fractions, make this switch. And now we'll have 1, 2, 4, 0 on top. Middle row stays where it is, 3, -8, -30, 28. Bottom row will now be 2, -3, -13, 14. Okay, so if I move to the middle row, I know I want this element right here to become a 0. To make that happen, I can multiply -3 times row 1, add it to row 2, and that'll be my new row 2. All right, top row, 1, 2, 4, 0. For my second row, if I multiply row 1 times -3, I'll get -3 plus 3, which is 0. Okay? -3 times 2 is a -6. -6 plus -8 is a -14. And then -3 times 4 is a -12. -12 plus -30 is a -42. All right, -3 times 0 is 0, and 0 plus 28 is 28. And then we will have 2, -3, -13, 14 for row 3. Okay, I need to make the -14 in row 2 become a 1. In order for that to happen, I can multiply everything in row 2 by -1/14. Remember, if you multiply by the reciprocal, you can get a 1. So 1, 2, 4, 0 on top. Middle row will be 0. -14 times -1/14 is 1. -1/14 times -42, you got really lucky. Because 14 goes into 42 evenly, that becomes a 3. And -1/14 times 28, 14 goes into 28 evenly, you're going to have a -2. All right, so 2, -3, -13, 14 is still the bottom row. So row 1, we're good for now. Row 2, we're good for now. Row 3, I need to make this 2 become a 0. To make that happen, let's take -2 times row 1 and add it to row 3 to get our new row 3. So I have 1, 2, 4, 0, 0, 1, 3, -2. Now on this bottom row, -2 times 1 on the top gives me -2 plus 2 is 0. Negative 2 times 2 on the top is a negative 4. Negative 4 plus negative 3 is a negative 7. And then negative 2 times 4 from the top row is a negative 8. Negative 8 plus negative 3 is a negative 21. And anything times 0 is 0, so 0 plus 14 is 14. All right, it's time to make negative 7 become a 0. To make that happen, we need to multiply 7 times row 2 and add that to row 3 to get our new row 3. So 1, 2, 4, 0, 0, 1, 3, negative 2. Now if I multiply that row 2 times 7 and add it to the bottom, 0 plus 0 is 0. 7 plus negative 7 is 0. And 7 times 3 is 21. If I add that to negative 21, 21 plus negative 21 is 0. And then if I multiply 7 times negative 2, I get negative 14. And negative 14 plus 14 gives me 0. Now notice what just happened. I have all zeros in the bottom row. Is that a true statement or is that a contradiction? Well, because that's a true statement, that tells me we have infinitely many solutions. Infinitely many solutions. And that's all you would have to do. Now, I want to back up to the one we skipped, number 9. And I have purposely waited until now to show you how to do this. It is not a requirement, but it might be helpful in checking your answers. When you test, I still expect you to show me all this written work that we have been doing together on these notes. But there is a way you can get your answer in the calculator. Now let me explain to you, if you have a TI 83 or 84 calculator, how this works. There is a matrix feature in the calculator. So if you were to hit the button on the top left that says second, and then you hit the button that is x to the negative 1 power. It's 3 below it in that first column, and it has the word matrix on top of it. It will take you to a screen, and across the top you will see some options. The first column is names. The middle column says math. You want to arrow over to the column that says edit. And then you will hit enter. And that's going to take you to a screen where you can actually type the matrix into your calculator. Now to do that, you always have to put the number of rows first times the number of columns second. So for this particular problem we're looking at, you would type in 3, hit enter, and then you would hit 4. Because we have 3 rows, 4 columns, counting that answer column. Now, once you do that, then you will simply type your elements one row at a time. So you're going to be going across the rows. You don't enter them in according to the columns. So if you've written down your matrix on your paper, you're just going to go across row 1. After you type a number, hit enter. It'll take you automatically to the next element, and then you type in that number and hit enter until you get all of them in there. Now after that, you want to go back to the button that says second, and you want to hit the button that says mode, which is quit. It gets you back to your home screen so that you're not still in that part of the calculator where you're entering in elements in your matrix. Now that you've entered that in, and if you just hit edit and enter, you're putting it in what's called matrix A. If you needed to put in more than one matrix, you could arrow down after you've hit edit, and you could type in something for matrix B or C or D if you wanted. What we need to do now is to tell the calculator what to do with this matrix. So if you'll go back to second, x to the negative 1, which is second matrix. This time, you need to arrow over to where it says math. And then you're going to arrow down until you find R, R, E, F. If you remember, when we first started this lesson, I wrote R, R, E, F on something that was in reduced row echelon form. And part of the reason I did that is because that's what you're going to need to look for in the calculator if you want to check your answer in the calculator. Once you find that, hit enter. And you will be back on the home screen and you will see RREF and probably in open parentheses, or it's going to be asking you, and where is your matrix you want us to perform reduced row echelon operations on. And what you would need to do is to go back and type in second matrix one more time. But this time, all you have to do is hit enter because you're just telling it the name of the matrix you want. If you put this in matrix A, once you hit second matrix, it's already highlighted A. After you hit enter, you would hit enter again, and what you will see is a solution matrix. You will have the zeros and ones in the first three columns, and then your excuse me, your solutions will be in that fourth column. If you were to put this in your calculator and work it out, you should come up with an answer that would look like this in the calculator. 1002 01 0 negative 1 and 0011. That means your ordered triple is 2 negative 1 1.